So you left your house and rode your bike into town at 9 miles per hour. Along the way, you got a flat, so you had to turn around and walk your bike back to your house, traveling 3 miles per hour. Again, we don't care about how reasonable this is, it's just the math. But if the trip down and back so that's total trip. That means the flat and then the walking home. It's going to take 24 hours. How far did you get before your tire went flat? Okay, so here's what I got just to get us started. Is the question is saying, how far did you get? How far? That's a distance on this one. If it was time, then it seems like those are being worded as how long, right? So I'm looking for some amount of distance on this one. So I'm gonna use D here as my distance. That's how far did he get before the tire went flat? So my distance, D is the distance, I guess in this case, you left your house, right? So that's the distance from your house to the flat, okay? Now, just as a quick reminder, hopefully this diagram helps. So you got your house right here, and yeah, that's a good enough house for me. If you want to be specific, put a roof over the head. But you're going to take your bike, you're going to ride it over here, and this is where you get your flat. Boom. Okay, so that's the distance from your house. How long is that? I don't know, but I do know that you rode your bike first, and then on the way back, then you walked. So you're going to ride the bike to the flat. Once you get a flat, you're going to walk home, hopefully with the bike and hopefully to fix the flat. But all this is going to take 24 hours, and that's going to be a key point for us. You got 24 hours, apparently, that you did this all in. Maybe no breaks, I guess. So the distance, okay, so we have two different frames of reference here. You got the amount of time that you were biking or distance you were biking. And then you also have whatever you did when you were walking. And then this is some kind of total, right? I guess it's kind of double the distance there. But I guess we're going to kind of have to take these two distances. And so I'm kind of looking at some kind of distance here, right? But how far did you, if the trip down and back took 24 hours, that's going to be important for us, okay? Because that 24 hours, that's the total time for both the biking and the walking, okay? So the biking and the walking are going to be related to some amount of total time, because that's a total that we have, and usually that means that when we take those values, we want them to equal some kind of total time. But the total time, you'd have time walking and biking, so we're going to have to add those two together, all right? But again, what are we looking at here? Well, we have a total time just directly as 24 hours, okay? So that means for me, we're probably looking at some kind of time formula where it's going to be distance divided by the rate. Now, D is the distance we don't know. So in these two fractions for biking and walking, they're the same distance, by the way. So you take some distance to bike, you take some distance to bike, you take the same distance to walk. But then again, we got to look at the rates. Well, the rates were actually given to us, right? So up here, it says that you were riding your bike at 9 miles per hour. So it's going to be a 9 in the denominator there for my biking, because remember, the rate goes in the denominator. And then when you walk, you're going at 3 miles per hour. So that's going to be divided by 3 right there. If I were to take, because these are times, distance divided by 9 is time biking, distance divided by 3 is time walking. If I were to add those together, I should get the 24, right? Now the D, whatever we solve for D, it's still the distance that you were, how far away you were when you biked or when you were walking. So right here, what I need is common denominators, and right now the 24 has the denominator 1. I also have denominators of 3 and 9. Well, 9 is a multiple of 3 and 1, so I'm going to keep that denominator the same, meaning my biking is just going to stay the same, but I'm going to start doing some stuff with my walking right there. So The walking, I'd have to multiply the 3 and the d by 3, right? So that'd be now 3d over 9. And then also the 24 and the 1. The 1 times 9, again, that's going to give us a common denominator of 9. 24 times 9, I don't know what that is, but my calculator does. 24 times 9 is 216. Okay, so again, we're adding these together, and this should equal the final number there. But from this, I'm going to now change it into a single equation, but without the denominator. So d plus the 3 distances should equal 216. And from here, we just take our like terms and combine them. So that would be 4 of those distances from your house. It's saying it's the same thing as 216. So finally, to solve this, I would just divide both sides by 4. And so the distance from the house appears to be 54. Now that's 54. We were looking at miles per hour, so that's going to be 54 miles right there. That should be our answer. Okay. Now, is it 54? Well, if you're 54 miles away from your house and you're biking at 9 miles per hour, that means you were biking for 6 hours. Okay. If you were walking, then 54 divided by 3 is going to be 18. So you would have walked for 18 hours after biking for 6, and that would total as 24 hours. 6 plus 18 is 24, so that checks. Now, there's another way to do it. I don't know how logical it is, but here's what we know. You got, you know that the biking was 3 times as fast as the walking. So you got, what this tells us is that you have 3 parts of walking and then 1 part of biking, okay? So the walking would have been 3 parts, and then the biking would have been 1 part. Well, what am I talking about 1 part? I'm talking about time, because 1 part of the time and 3 parts of the time. Again, how do we know that? Because biking was 3 times as fast as the walking. If it takes 24 hours, then we can take that 24 hours and break it up into increments. So since I have 4 total parts, biking and walking, I would then take 24 and divide it by the 4 parts. This tells us that each increment is in 6 hours, okay? Now this also tells me that they were biking, because biking is 1 part. They biked for 6 hours, and we already found that out here, right? But in addition to that, the walking would have been 3 times the 6. And again, that's where we get the 18 hours. Well, if they were biking for 6 hours, you could have said, well, 6 times the 9 miles per hour would have given us 54 miles. And then again, we would have confirmed that, because we see now that we were walking for 18 hours at 3 miles per hour. 18 times 3 is also 54. So again, is that the most efficient way to do it? I don't know, but it is a way to do it. And it would have been a way actually without having to put together all this garbage. But again, some students don't understand that, so this is actually the garbage. It's up to you.